Welcome to the Physics Trek channel, where we supply incremental success. That means if you stick with a program, little by little, you will achieve your goals. That's a promise. I'm Alan J, here with yet another work solution to help you improve your physics and showing you best practice, answering those thorny little questions that just make your head spin. Last time I mentioned about G, the acceleration due to gravity, being more or less constant for everyday use, and that still holds. But I thought before we begin, I might elaborate a little on why in reality G isn't constant. It is all to do with how far away you are from the surface of the Earth, where its value is a maximum. So high up on a mountain, G is less than if you were at sea level, and this is where you might have to scratch your head a little. The value of G also varies depending where you are on the planet's surface. What? I can hear you say. How does that work? Well, it's all to do with the actual shape of the Earth. It's not a perfect sphere. It bulges out at the equator and is flattened at the poles. It's what's called an oblate spheroid. Anyway, the upshot of this is that some places, like at the poles, are closer to the centre of the Earth. The value of G there is greater. At the equator, places are further away from the centre. There, G is less. So the value of G is really an average, true only for a completely spherical planet, but it's good enough for most things. So getting back to our question, it is another two-parter, but unlike the previous question, it does require some thought and planning. This time the object is projected upwards from a tower, and after reaching a maximum height, falls to the ground. You are asked for 2 times the time to reach maximum height and the total time from the initial throw until the object hits the ground. So let's get the show on the road. Here's our question. Question number 4. A stone is thrown vertically upwards with an initial velocity of 29.4 meters per second from the top of a tower 34.3 meters high. Find 1. the time taken to reach maximum height, 2. the total time which elapses before it reaches the ground. And first down the side, for quick reference, here are our 2 sets of equations for upward and downward movement. Now we're going to do things different this time. We're going to write the diagram down first. Here's our tower. Okay, it's D meters high. That's 34.3 meters. The stone's thrown up from the top of the tower. The stone starts off with initial velocity 29.4 meters per second. It ends up with final velocity v1 0 meters per second. It travels a vertical distance s1 meters, and when it falls, its initial velocity 0 meters per second is u2. It takes time t2 seconds to fall, and it falls a distance s2 meters. Again, let's not forget the acceleration due to gravity g, which is 9.8 meters per second squared down. Okay, here's our information. U1 is 29.4 meters per second, V1 is equal to 0 meters per second, D is equal to 34.3 meters, T1 we need to find, T3 is the time the object is in the air, that's T1, the time to go to maximum height, plus T2, the time to fall to the ground. Let's spend a little bit more time on this diagram. Okay, the height of the tower D is 34.3 meters. The object sets off velocity u1 29.4 meters per second, ends up with velocity v1 0 meters per second, takes time t1 to reach that maximum height. It travels a vertical distance of s1. When it falls from rest. u2 is 0 meters per second. It takes t2 seconds to fall to the ground. It travels a vertical distance of s2 meters, and it falls under gravity, where g is equal to 9.8 meters per second. And we need to find out what t1 is. That's the time from the top of the tower to highest point. And t3, which is the total time the object is in the air, that's t1 plus the time t2. That's the time it takes for the object to fall to the ground from its highest point. Okay, let's get on with the question. Okay, we need T1, so the obvious equation is V is equal to U minus GT. We've got V, U and G, So all we have to do is rearrange the equation to make t the subject. So we take the minus gt to the left and the v, and change the sign, and the v to the right and change its sign. So we get gt is equal to u minus v. We divide both sides by g, so we have t1 on its own. t1 is equal to u minus v divided by g. Now it's just a case of putting the numbers in. t1 is equal to 29.4, which is u, minus 0, which is v, divided by 9.8, which gives us 29.4 divided by 9.8, which equals 3 seconds. Okay, now to part 2. Now, the total time in air of the object is t3, and that's equal to the time to maximum height, t1, plus the time to fall to ground, which is t2. So t3 is equal to t1 plus t2. Before we go any further, I think we need to remind ourselves of the distances involved. So let's redraw a little bit of the diagram. Okay, we have the height of the tower d, we have the distance from the top of the tower and the highest point s1, and the distance between the highest point and the ground s2. The relationship between the three quantities is s2 is equal to s1 plus d. Now we already have d, and we can work out s1 because s1 is equal to u1 t1 plus a half a t1 squared. We already have u1, t1 and g. So putting in the numbers, s1 is equal to 29.4 times 3 minus 0.5 times 9.8 times 3 squared, and this comes to 88.2 minus 44.1, which comes to 44.1 meters. Now, as we said before, S2 is equal to S1 plus D, so putting the numbers in, S2 is equal to 44.1 plus D, which is 34.3, and that comes to 78.4 meters. S2 is 78.4 meters. Now let's not forget what we're trying to do here, trying to work out T2 by working out S2. We worked out S2, and now we need to write down the equation. S2 is equal to U2 T2 plus a half G2 squared, and make T2 the subject of the equation. Now the first term goes out because U2 is equal to 0. So we're left with S2 is equal to a half GT2 squared. To put T2 on its T2 squared on its own, we multiply both sides by 2 and divide both sides by G. So we're left with T2 squared on the right. Turn the equation around, so T2 squared is equal to 2S2 over G. Take the square root of both sides, so we're left with T2 is equal to the square root of 2S2 divided by G. Okay, now let's put some numbers in. T2 is equal to the square root of 2 times 78.4 divided by 9.8. Now that comes to 4 seconds. Now then, let's not forget what we're after. We're after the total time to reach the ground level, and that's T3. T3 is equal to T1 plus T2. So let's put the numbers in. T1 is 3, T2 is 4, so T3 is 7 seconds. And now to our answer summary. Okay, part 1. The time to reach maximum height is 3.00 seconds. Part 2. The time to reach ground is 7.00 seconds to 2 decimal places. Well, there's another one in the bag. My fervent hope is that this little offering has been of help to you in some way. And if you enjoyed the video, I'd really appreciate you giving the channel a like, a favourite or a subscribe. Remember, most of the unanswered intermediate mechanics questions are on the Physics Prep website now. So have a go at any of them and stay ahead of the game. Anyway, do look out for the next work solution on the topic accelerated motion under gravity, number 5. It's on its way as we speak, and if you want to recap on the previous video, just click the link. Don't be shy. Any comments on the show, suggestions to make it better, or ideas for new videos are always welcome. Bye for now.